Hello everyone! Today, our group will be presenting our FAC1004 Advanced Mathematics 2 project titled Geometric Extremals in the Complex Plane.
I choose Z equal to 6 plus 8I and R as 3. I use the formula in green to find the Z min and Z max. I do a confirmation here and we can see that it is the same value as using the basic formula. By using the true coordinate, we will get y equal to 4 over 3x. We insert the straight line equation into the locus equation, then we will insert the x value into the y equal to 4 over 3x. Then we will get the point of intersection for each Zm and Zmax. Zmax is the point that is the farthest from the origin while Zmin is the closest. We define unit vector equal to Z0 over magnitude Z0. This vector has magnitude 1 and point from the origin toward the center. Zmax move in the direction same as the unit vector, while Zmin move the opposite from the unit vector. Here we just substitute y equal to mx into the circle equation. The relationship of y equal to mx is tangent to the circle because we want to find the max min argument z, so it must touch us only one point. So to find the slope value, we need to make the discriminant equal to 0. Then when we solve the equation, we will get m max and m min. So here we just use the formula inverse tangent of the gradient. Here we use the quadratic formula, then we just insert the max min gradient in the x equation, which will then give us the z for the min max argument z.
Next, moving on to the GeoGebra illustration for the circle. The value of r when the circle first touch the locus is equal to 7, and when the locus is perfectly inside the circle, the value of radius we get is 13. And from the value of m we get from the calculation, we get two intersection points. And to find the argument minimum and argument maximum, we need to substitute the complex number into the r times y over s. So we got two argument here. So for the maximum argument, we got 70.5877. And for the minimum argument, we got 35.672499.
Next, I will present about the manual proof about the elliptical locus. So first, I let Z1 equal to 5 plus 2i and Z2 equal to 1 plus 2i, and my A will be 6. Then I sub in the value into the distance formula. So after that, I square both sides and I arrange and I square both sides again, and this is my final elliptical formula. Relation that means Z max, I differentiate the ellipse formula and I'll get this answer. Then I square the distance formula and I'll differentiate it, and I sum in the value of dy over dx before into this formula, and I will get some complete formula like this. Because of the equation is too complex, I add AI to do this and I will get the value of x min, which is 0.63. Then I find y, which equal to 0.647. Then the z modulus equal to 0.903. Then for the x max, I will get 5.82. Then I find y equal to 2.737 and the modulus z equal to 6.43. For argument extrema, I sub in the equation y equal to mx equal to ellipse equation. Then I let the discriminant equal to 0. Then when I sub in, I will get the value of m, which is negative 1 over 12. From the value of m, I will get the minimum argument, which is arctangent negative 1 over 12 equal to negative 4.76. For the maximum argument, because of the ellipse touch the vertical line, so that the suitable value of x equal to 0. So I sub in the value of x, then I will get the maximum argument equal to 90 and the z equal to 0 plus 2i.
Okay, next, we need to find the dy over dx using the implicit differentiation. The first step is to differentiate each part in the equation, and then we arrange it to find the dy over dx, and we will get negative 5x minus 3 over 9, y minus 2. Then, we need to set the derivative of the distance to 0 to find the x and y value. First, we will get the x value is 3, and then we substitute back the x value to the original equation, and we will get the y value, which is plus minus 5. After we find the x and y value, we will get 2 points, which are 3, 2 plus 5, and 3, 2 minus 5. And then we need to convert this into complex number, and we will get 3 plus 2 plus 5i and 3 plus 2 minus 5i.
For the ellipse, the radius when the circle first touch the locus is 0.891, and the radius when the locus is perfectly inside the circle is 6.44. And the argument we get from here is, we get two argument here, which is 90 degree, and the other one, for the minimum argument, we get negative 4.7636 degree.
For the circle, the manual and GeoGebra results are consistent. The equation Zmin and Zmax match exactly. The argument values are also very close with only minor rounding differences. Overall, the visual confirms the exact manual results. Rounding. For the ellipse, the manual and GeoGebra results are consistent. The equation matches it exactly. The minimum and maximum modulus values are very close with just minor rounding differences. The argument values match exactly, confirming the correctness of the extrema. Overall, the visual method supports the exact algebra result. Exactly.